L'Hopital's rule, indeterminate form. Back in the first chapter we did, we took limits. And sometimes when we substituted in, we got what we call the indeterminate form. 0 over 0, infinity over infinity. And sometimes we could do some algebra, for instance, factoring this numerator to 2x minus 1, which is 2 times x minus 1, x plus 1, so the x plus 1 cancels, and you're left with 2 times x minus 1, and now you can substitute in and get the answer. Or, in the last chapter, we talked about limits approaching infinity, and we said if we look at the highest exponent term, we could then divide everything by that, in this case x squared, and you end up with 3/2. But we can't always do a algebraic technique. And one of the other things we did back in the first chapter is try a table, and we're trying to find the limit of this guy as it approaches 0. So we put in values for x closer and closer to 0, and we made a good guess that 2 might be the answer. But that's a guess, not guaranteed. Algebraic techniques guarantee that what we do is correct. Charts give us a good indicator. And we had to use delta epsilon definition to try to do that. But we have another tool that we could use, and it's called L'Hopital's rule. When you do direct substitution and you get the indeterminate form. And L'Hopital's rule says if you can take the derivative of the numerator and the derivative of the denominator and try the limit again, and you get a result, then that is your answer. So L'Hopital's rule says when you get an indeterminate form, 0 over 0, infinity over infinity, minus infinity over infinity, or several others that we're going to talk about in the next couple of problems, then we can use L'Hopital's rule. If we can write it as a fraction, numerator and denominator, then take the derivative of the numerator, take the derivative of the denominator, and see if you can evaluate the limit. For example, one that we just looked at that we really couldn't do, the limit as x approaches infinity of e to the 2x minus 1 over x. And we did a chart with that, and we found out the value was guessed to be 2. So let's see if it really is. Well, when you put 0 in, e to the 0 is 1, 1 minus 1 is 0, x is 0, 0 over 0. So this is an indeterminate form. Always show that before you go on. Show that what you start with is indeterminate. Then L'Hopital's rule says take the derivative of the numerator, take the derivative of the denominator. You do that, you get 2e to the 2x over 1. And now evaluate, and we get the 2, the answer that we said would be. So L'Hopital's rule. L'Hopital's rule. The limit as x approaches infinity. Natural log of x over x. Well, if you substitute in, natural log of infinity is infinity. So you get infinity over infinity. Always write down what you get. That is an indeterminate form. Therefore, we can use L'Hopital's rule. Take the derivative of the numerator, which is 1 over x. Take the derivative of the denominator, which is 1. And so we get 1 over x. As x approaches infinity, 1 over x is going to 0. And so we have determined what the result is using L'Hopital's rule. Using L'Hopital's rule. Limit as x approaches minus infinity of x squared. Well, put minus infinity in, you get infinity. E to the minus x, that's e to the minus 1 over x. So that's, e to the minus x, putting in minus infinity, minus infinity, e to infinity. So we get infinity over infinity. L'Hopital's rule. So derivative of x squared is 2x. The derivative of e to the minus x is e to the minus x by chain rule minus 1. Substitute minus infinity in. 2 times minus infinity is minus infinity. E to the minus infinity, we already found out, was infinity. the opposite of that. And so it's minus infinity over minus infinity. It's indeterminate again. That means I can use L'Hopital's rule. You can use L'Hopital's rule as many times as you get that result, the indeterminate. So the derivative of 2x is 2. Derivative of e to the minus x was already minus e to the minus x. Minus that gives me e to the minus x. 2 over e to the minus x was infinity. So 2 over infinity is 0. And we have evaluated using the indeterminate, using L'Hopital's rule. Now, the indeterminate rule runs around in a variety of ways. Here's one of them. If you have the limit of e to the minus x, square root of x, as x approaches infinity, well, e to the minus x is e to the minus infinity, which is 0. Square root of infinity is infinity, and so we get 0 times infinity. Well, that is an indeterminate form. Why? Because we can show it. E to the minus x really means e to the x in the denominator. So I've rewritten my limit as a fraction. And when I put infinity in, square root of infinity is infinity, e to infinity is infinity, this is infinity over infinity, indeterminate form. Which means, since it started with that, and now I can show 0 times infinity is indeterminate. It means L'Hopital's rule. So the square root of x is x to the 1/2, so it's 1/2, x to the minus 1/2, so it's 1 over 2 to the square root of x. E to the x is e to the x. So we end up with the limit as x approaches infinity is 1 over 2 to the square root of x, e to the x. 1 over infinity is 0. We have evaluated using L'Hopital's rule. We've evaluated using L'Hopital's rule. So L'Hopital's rule runs around in a variety of ways. Here's another way. 1 to infinity. Let's show it. 1 plus 1 over x to the x. X approaches infinity. 1 over infinity is 0, so this is 1 to infinity. Well, I don't know what that is. Is it indeterminate? Well, let's find out. Let's assume that we can figure it out. So it equals something. I'm going to use y. So this limit equals y. Problem is the exponent. So to get exponents, I use the natural log. So if you use the natural log of both sides, you get the natural log of y. Natural log of a limit is the limit of the natural log. So the limit of x times the natural log of 1 plus 1 over x. When you take the natural log, the x becomes a coefficient, a number. Well, don't want to mix with this guy, so 1 over x could be written as 1 over x in the denominator. I can write this as a fraction, because when you divide by 1 over x, that's the same as multiplying by x. When I put infinity in here, 1 over infinity is 0, so it's the natural log of 1, which is 0, and 1 over infinity is 0, so this is 0 divided by 0. And since I'm just using algebra rules, and I haven't done anything wrong, that means that 1 over infinity does equate to 0 over 0, indeterminate form. So it can be done. So you take the derivative of log is du over u. The derivative of 1 plus 1 over x squared is minus 1 over x squared. 1 plus 1 over x is minus 1 over x squared over 1 plus 1 over x du over u. And the derivative of 1 over x is minus 1 over x squared. So this minus 1 over x squared and that minus 1 over x squared cancel each other out to 1. Still left with 1 over 1 plus 1 over x. As x approaches infinity, that's 1 plus 1 over 0, which is 1. Now, that's not the answer to my question. My question is, what's this limit? This is the answer to the natural log of y. So if the natural log of y is 1, that means y is equal to e, and therefore this limit equals e. In fact, that's the definition. You go back to chapter 1 and look at it. That's the definition of e. And so we have evaluated using L'Hopital's rule. We have evaluated using L'Hopital's rule. Okay. One more Another way L'Hopital's rule runs around is 0 to the 0 power. The limit as x approaches 0. Well, the sign, if you're approaching 0, the sign of 0 is 0. So this is 0 to the 0 power. Again, I don't know what that is. I'm not sure what that value is. So I need to use L'Hopital's rule to figure it out, perhaps, if this is indeterminate. Well, is it indeterminate? Well, let's assume we can determine it. Because again, our problem is an exponent. So take the natural log of both sides, and now we've got the natural log of y equals the limit of the natural log of the sine of x to the x, so that x comes out as a coefficient. Log of sine of x. Again, I don't want to mess with the log, guys, so I'll leave that in the numerator. Because I'm using L'Hopital's, I got to write it as a fraction. So x in the numerator is the same as 1 over x in the denominator. And if I approach 0, the sign of, as you're approaching 0, it's getting very small. The log of a very small number is minus infinity. And 1 over x is infinity. So minus infinity over infinity, indeterminate form. Therefore, this has just been proven to be indeterminate. So use L'Hopital's. du over u. So the derivative of the sine is cosine. Cosine over sine is cotangent. The derivative of 1 over x is minus 1 over x squared. Make it a nicer fraction. Since the cotangent is 1 over tangent, I can make this tangent, and minus 1 over x squared becomes minus x squared. Put 0 in. Tangent of 0 is 0. 0 squared is 0. There it is again, indeterminate form. And since these guys are all equal, see the equal sign? These are all equal. That means that 0 to the 0 power is indeterminate. So use the L'Hopital's rule. Derivative of minus x squared is minus 2x. Derivative of the tangent is secant squared. Secant goes with cosine. Cosine of 0 is 1, so the secant of 0 is 1. So we get secant squared, so we get 1. And minus 2. Sorry, we're looking at 0. So the secant goes with cosine. So the secant is 1 over cosine. And so this becomes infinity. Right? So, no, I'm sorry, I was right. It was 1. Take it back. It's 1. This is 0. 0 divided by 1 is 0. That's the natural log of y, not y. So the natural log of y equals 0 means y equals 1. And we have evaluated using L'Hopital's rule. The L'Hopital's rule runs around several ways. There's one more. You can look at that example. But here's how 0 divided by 0 is the indeterminate form. Okay? But things that are related to that are infinity over infinity, minus infinity minus infinity, 0 times infinity, 0 to the 0, 1 to infinity, 0, or infinity to 0. Those are all indeterminate. These are not. So you can't use those. So L'Hopital's rule. But you only can use L'Hopital's rule if you get the indeterminate form. Again, I get people later on, Calc 2 and 3, they look at this. What's the limit as x approaches 0 of e to the x over x? And they go, oh, wait, that's 0 in the denominator. Oh, I can use L'Hopital's rule. So e to the x, the derivative is e to the x. X is 1. Substitute in, and you get 1. But this is not a candidate for L'Hopital's because e to the 0 is 1. So this is 1 over 0, not 0 over 0. So it's not L'Hopital's rule. In fact, the answer is infinity. So incorrect use of L'Hopital's rule. Use L'Hopital's rule correctly. So go back, look at some of the examples. There's a pen cast up. There were a couple of videos involved. Check them all out and use L'Hopital's rule when you need to.